4.2, we're still graphing, but this time it's standard form of quadratics. Alright, and just like we were doing in section 1, it could be that it's an equation or a function. So for this one, we're going to put f of x equals and y equals, and we're just going to write it one time because it's the exact same part of the formula, or part of the equation. The only difference is sometimes they start with f of x equals and sometimes it starts with y equals. But it's still the same basic setup every single time. And those a, b's, and c's, those are going to be whole numbers or real numbers. And even more than that, most of the time, when you do a, b, and c, they're usually going to be integers. You'll get a couple of fractions. Every now and again on some problems, you'll get maybe one problem that's got a fraction mixed in with it. And when you do that, it's still going to work its way out because it's going to, the fraction itself shouldn't be any big deal when you start working through the problem. So overall, it should be really a non-issue when it comes to the part of what we're doing here. Alright, here's a big giant star, not just a little star. This is a big giant star, because this is the one big thing you have to get today. If you get this, everything else is just great, because this is the one big thing you've got to get today. Because on this part of it, we don't have, that if we had the parentheses like we had back here, when we were doing this one, we could find the vertex really easy. That's the problem, that's the difference today, is you're not going to have any parentheses. So we have to find the vertex. So here we go. Here's how we're going to find the vertex. So to find the vertex, which is, again, they're going to show that as h and k for the two parts of the ordered pair. So to find the h, which is the x value, you're going to do one simple little thing. It's going to be negative b over 2a. Now, and I'm going to add one thing to this, and I started adding this probably in the last year or so. When you do the b and the a, put those in parentheses. And that really helps, especially when this b value winds up being negative. Sometimes people get thrown off, but we're going to put that in parentheses because that will kind of separate this thing out when we're working through it here. Okay, and to get the k, which is the y value of the vertex, you're going to have to, it's not really one little thing you're going to do, it's more what you have to do. You have to plug in this x value of negative b over 2a into the original equation. Okay, and draw a box around that to kind of highlight it, because that is the one, that is really all the work you're going to do today, is doing that part right there. Now, here's the one thing that's going to be different, a way about the book is going to do this. When they talk about the book notation of vertex, they're not going to give you the h and k like this. When we're doing this part in section 2, they're actually going to make it look like this. That they're going to tell you that it's going to be negative b over 2a for the x value, which is what we did right here for this part of it. The second part is they're going to show you it's going to be f of negative b over 2a. So when you see the vertex in the book or the online homework, if you're doing the help me solve this or look at an example, when you see them doing the vertex, they're not going to show it quite like this. They're going to show it more like this. So just realize that when you're working through the online homework, through the textbook, this is kind of what you're looking at more than anything else. Alright, here's where we get to add in one little shortcut also. the c value, because we're doing back up here, we're doing the x squared plus bx plus c when we're going through this one. One easy little shortcut you get, the c value is the y-intercept. So that's one point on the graph that you get without having to do anything at all. You just look at it, and there you go. That's your y-intercept. Okay, and then just one little reminder. Remember that the a value determines the direction of the graph. Then when A is positive, the graph looks something like this. And when your A is negative, the graph will look something like that. And remember, when A is positive, when you have something like this, and your vertex is here, that's the minimum value. When your vertex is here at the top, that's the max value. Now, and again, that's what we did in section 1. So that part of it is still the same thing. That part doesn't change. It's the A value. It's whatever's in front of the x squared. That still gives you the overall direction of whichever way the graph is going to go. So that part doesn't change at all. It's just now we don't have the parentheses behind the x to have us work through everything. All right, so here's what we're going to do. Now that's the whole setup for what we're doing today. That is everything that's here. So what we're going to do is we're going to give you a problem, and we're going to go back and do everything that we did Monday. But again, it's just getting through the setup to get everything to be what it needs to be for this thing. And we'll do 3 examples because we'll show you a couple of different things off each one of them. And once we do that, then we'll be ready to let y'all work on a few problems yourself. So here's your list of things you have to find for this part. You're going to find the vertex. Let's do the axis of symmetry. Let's do the max or min value. Let's find the y-intercept. Let's do one other thing here. Let's write this one in graphing form. Or I think they call it vertex form. And then finally, we're going to graph this thing. Now, here's where they kind of contradicted themselves. On Monday, when we were doing 4.1, I think they called this graphing form of quadratics. We call it, in section 2, they changed it and call it vertex form. So when you see vertex form, just realize that's graphing form. So section 1, they called it graphing form. Now they've changed it back to vertex form. So it's basically the same thing. They just call it something different there. Every book has a little bit something different that they call it sometimes. So. Okay, so here we go. We're going to do 3 of these examples, and this will be it for today. So example 1, let's do this. Let's go with 2x squared plus 8x minus 1. And before you do anything, tell me what the A, B, and C values are. A is 2. B is positive 8. But again, you don't need to put the positive. And C is negative 1. Now, there's always two things that you can get without doing anything at all once you tell me what A, B, and C are. The two things you get are the A value is 2, it's positive, so the one thing you know is the graph looks something like this. Now, where exactly it's going to be, we don't know that yet, but we know the graph has to look something like that when the A value is positive. So you got that part of it. The other part is, if the graph is like that, this is at the bottom. If that's at the bottom, that means it has to be a minimum value. So we actually have part C right here. We know it's a minimum. We just got to tell what that minimum value is, but we already know that it's going to be a minimum. And then the one other thing you get from this one that you get without doing anything at all, the C value right here, that means that your y-intercept. And on the test, I'll take either way. You can tell me it's negative 1. I think online they're going to make you do it as an ordered pair, so that would be the 0.0, negative 1. So again, there's one that we can do. We can do part D. We got it checked off. That without having to do anything at all, you just look at it and you can tell me what the y-intercept is going to be. Okay, now to get the vertex, which will get us all this other stuff we need here, we've got to get the vertex first. So the very first thing is to get the vertex. Which is HK. And again, the H value was negative B over 2A. And again, something small that I've added in probably the last couple of times I started teaching this. When you do the negative B over 2A, go ahead and put parentheses around the B and the A. So it's the negative of 8 over 2 times 2. So that's negative 8 over 4. So that's negative 2. And most of the time, the H value should be a whole number. Again, there might be one occasion where that might come out. When you plug these numbers in, it might be a fraction, but 90% of the time, that should be just a plain integer. Either it could be positive or negative, but it's usually an integer form when you go through that one. Okay, so we already know the x value of the vertex, which is negative 2. To get the next value, which is the k value, you're going to take the original function that we had and plug in negative 1. And this is exactly why we did the whole function notation thing on the last test, because you've got to know how to work through function notation to make this thing work out. And most people did pretty well, and I'll get that test back to you either today or tomorrow, 1 to 2, when we were working through these, that most people did pretty well plugging this part in. The only thing that threw people off seemed like the absolute value. Got a few people here and there. The good news is there's not any absolute value on this test because it's all quadratic. So that part of it I think will be in good shape plugging these in. So what we're going to do is we have to take this negative 2 and plug it in. So when you plug in a negative 2, we're going to take out the x and replace it there. Take out the x, replace it there. Take out the x and replace it there. Okay, now one small thing, and I think I only noticed maybe once or twice that did this. When you plug in the number, remember, you don't do anything with this part. That's just there to let you know that I plugged negative 2 into this function that's here. So once you do this, all the work is over on the right side. You don't do anything at all to the left-hand side. All right, go through your exponents. Negative 2 squared is 4. So we get the exponents out of the way first. And once the exponents are gone, now we can do the multiplication. 2 times 4 is 8. 8 times negative 2 is a negative 16. Eight minus 16 is negative 8. Negative 8 minus 1 is negative 9. So that's our second value that goes in right there for a vertex. Okay, now that you have the vertex, again, the h value is always going to be the same thing. It's negative b over 2a. To get the y part of it, it's always going to be the same thing. You're going to take this number and you're going to plug it back into whatever equation you had in the beginning. And from there, it's just work it out. Just always some exponents and some multiplication, a little bit of adding and subtracting when you're going through here. Once you've got the vertex, everything else spins off this. That your axis of symmetry is going to be the x value. That's x equals negative 2. The y value, that's going to be the max or the min value. What did we say this was? This was the minimum from back up here. So if they ask you for the min value, it's going to be that second value that's there. And we already had the y-intercept, and we'll rewrite that one again. The y-intercept was at 0, negative 1. Okay, now here's the one that takes a little bit of practice. When you do this in, so this was part A, this was B, this was C, that's D. So when we do part E, when you do the vertex or the graphing form, that's our form. And we've got to plug in the a value. Sorry, take that negative out there. It's not negative, it's just a. Oh, sorry. We've got to plug in the a value, and then you've got to plug in the vertex. So for this one, the a value was 2. Now, when you plug in the negative 2, you make it minus the negative 2. So really for this one, that's 2 times x plus 2 squared minus 9. Yeah, big thing is, again, just like we did on the last part of it. You notice how the number changed on the inside? Because it's x minus h squared. So this one, if you take this out, that's where we change the sign of it, change it from positive 2 back to a negative. And the second number, it's always the sign that it is. So that would be the vertex form. Now, you're not going to have to do that on every single problem, but we're going to go ahead and show it to you just to make it a little bit easier when you do have to do those problems when you're going through here. So all you're doing is you're plugging in the vertex, first number on the inside, second number that's on the outside. And again, the a value always goes in front there. Because again, the a value is kind of like the slope. Not exactly slope, but it's kind of like the slope. Alright, so now we've got to graph it. And because the vertex is at negative 2, negative 9, we're going to need a lot of room at the bottom of the graph. Okay, I'm going to cover that part up now just because we'll go back to here. Alright, and again, vertex, that is the most important point on the graph. So that's at negative 2, negative 9. So make sure that one's good because everything's going to spin off this one. So negative 2, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll put us right there. Okay, I'm going to go ahead and draw the axis of symmetry because that's actually going to help us out when we do this part of it. When we graph it in a second. Alright, so there's the axis of symmetry. Now, and there's actually 2 points you can get to help you here. The y-intercept is a point that you don't have to do anything. That you go to 0, negative 1, you know the graph has to hit that point because that's the y-intercept. Now, when you're graphing these by hand, when we're doing this on the test and you have to graph this by hand, here's where it helps you out a little bit. If this is 2 spaces to the right of the line, you got to have the exact same point in the opposite direction. You got to have the exact same point 2 spaces to the left of the line. And that's what the axis of symmetry does, is once you know one point on the right side, you automatically know it's the exact same point that would be on the left-hand side. Now, somebody may be saying, well, didn't we kind of use the slope, the A value, to help us graph also? Yes, you could still do the same thing. That for this one, if you want to think about that as being the kind of slope, because again, it's not technically the slope, but it's kind of like slope. That would be 2 over 1. So if you go up, if we went back and drew this graph in, just with that point, we have something like this. That if you went back and used your kind of slope, it should match on that same point. We'll go up 2 over 1. That would be the next point that would be on the graph right there. And then go back 1, and that would be that point that would be right there. So you can still use what's kind of like the slope to help you get to the next point. So that's going to get you the next point that's up here. The y-intercept, though, is going to get you a point that sometimes is a little bit farther off for what you have to do. Now, online, again, as soon as you get any one of these points, it's automatically going to draw the rest of the thing in to get you what you need there. Okay, so domain is always negative infinity to infinity. When you do the range, it's the bottom of the graph to the top. And the good thing is that when you have the max or min value that we had back here, if that's the minimum value, that's the bottom. Because that's the bottom of the graph that's here. And again, we're going to box that in. The top of the graph is going to go forever, so your top of your graph would go run to infinity. So if that's the minimum value, that's the bottom. In a minute, we're going to do one where it's the max. That's going to be the top value, which then makes it going to go the other direction. And that's what we're trying to get you to see, is that max or min value, that's either if it's the minimum, that's the bottom of the range. If that's the max, that's the top of the range. That's as high as you can go there. All right. So any thoughts, any questions on any of that part before we move on to the second? All right. Example 2. Okay, so for this one, let's go with negative x squared plus 4x minus 5. And we're going to do the same thing we did on that when we're going to find all the different parts of this thing to make it work out. And again, to do anything, we've got to get the a and the b and the c values here. So the a is negative 1, the b is 4, and the c is negative 5. Alright, and with that, two things you get right off the bat without having to do anything at all. The a value, again, gives you the direction of the graph. So if it's negative, it's going down, which means the vertex is at the top, which means that's going to be a max value. And the c value, that is your y-intercept. Okay, so there's the two things you get without doing anything at all. Well, really three things. You know the shape of the graph, the shape tells you whether it's max or min, and then you also have the y-intercept. Okay, so here's we have to do all the work. To get the vertex, which is the h and the k, the h is negative b over 2a, and again, just to be on the safe side, we're going to put the b and the a in parentheses. That is minus 4 over 2 times negative 1. So that's negative 4 over negative 2. So for this one, the h is not negative 2, this time it's a positive 2, because those two negatives will cancel out to make it a positive. And to get the k value, Now again, you can put the f of x that's here, or you can just tell me that to get the k value, what we're going to do is we're going to take that original part of the function that we had, and we're going to plug in the 2. So take out the x, put in a 2 there, and a 2 there. And here's where if you put those numbers in parentheses, it helps out. Because sometimes people get to this negative, and they're like, ooh, what do we do with that negative? Does that go inside or outside? This 2 is always on the parentheses by itself. Everything else has to go on the outside. So that negative goes here, and that squared goes there. And that is the biggest one help that you get if you put the numbers in parentheses, because if you happen to have anything around it, everything around it has to go on the outside of that number. Oh, I'm sorry. That's -5. I looked at it wrong. Thank you for catching that. That is a -5. I'm sorry. Wasn't paying attention when I copied it down. Now that's where if I was one of those teachers, I'd say, oh, just make sure you're paying attention. No, I made that mistake. So, Kenzie, you caught that, right? Oh, that was okay. That was Kevin caught it. Okay. All right. So from here, before you do anything, don't worry about the negative because you have to do the exponents first. So 2 squared is 4. The negative stays in front of that number. So it's not -2 squared. It's 2 squared, and then you put the negative in front. Then we've got the multiplication. 4 times 2 is 8. And then we have the -5 that goes behind it there. Okay, -4 plus 8 is 4. 4 minus 5 is -1. And that's the k value for the vertex we're looking for. So that tells us what our vertex is. It's at 2, -1. Okay. And the A part is that when you have to find the vertex, that's the hardest part of what you have to do. Everything else from there goes pretty easy, because the B part is when it asks for the axis of symmetry, that is just your x value. Vertex equals 2. The C part asks for a max or min, and now back from the A value, we know this thing was going to be a max, and that max value is going to be at -1. We've already got the D part right here. That was the y-intercept, so that was at 0, -5. And this is the part that you won't have to do this every time, but again, we're doing this just to be on the safe side. You have to put it in graphing or vertex form. Now the A value was -1. And again, your vertex, you're going to change this sign because it's going to be x minus 2. And then the k value, it is what it is. So the A value always goes first. Again, when you put in the x value, the vertex, you're going to change that sign. The second number, you don't change the sign there. Okay, and with that, we've got everything we need to graph it now. And this one's going to be a little bit more towards the bottom because of the shape of the graph, so you can leave it a little bit more that way. Okay, so everything starts with the vertex, so we're at 2, -1. Now, here's one thing you could always do to kind of do. We've got 2, -1. So that puts us right here. And again, the one other point you have without doing anything at all is that you know this thing has to go through the y-axis at -5. So go to 1, 2, 3, 4, 5. And you've got to have a point right there. Because that part was given in the part of the equation. That was the C value. So there's our axis of symmetry. And again, for this graph right here, this is 2 points to the left. We're also going to need the same thing, 2 points to the right. And you could use that to help you find these graphs just with those 2 points right there. And again, if you're asking, well, why didn't we use that A value, which is kind of like the slope to get us there? You can still use that value because this would be down 1 over 1. That's going to be this point that's right here. Down 1 over here, that's the other point that's right there. So that A value, that's still kind of like your slope. It's still going to be there, but sometimes when you put the y-intercept, it automatically puts it, and you don't have to use the A value to get you there. Again, the one thing that's always the same, domain is always negative infinity to infinity when you do your range. And again, this thing is going down, so the low point of the graph goes to negative infinity. It does stop here at the top, and again, that's what we're going to use the max value of. That's the top of the graph, that's at -1, so we're going to box that in. Now, and on the online homework, again, I know there's a couple questions where they have it do less than and greater than. If these arrows are pointed down, this is the same thing as the y value would be less than or equal to -1. Because, again, the arrow is pointing down, so they're going less than that number. So negative infinity up to negative, because the arrows are going down up to -1. And, again, that max value will either be the top of the graph or the bottom of the graph, just depending on which way the graph is going. All right, let me show you one more. And this one is one of those where it's almost so easy that it's hard, because this is one of those questions where sometimes people, they'll go through the formula and get this one and they're good with it. Sometimes they'll give them one that's kind of easy, and it's almost one of those where it's too easy where it throws people off. So let me show you an easy one that sometimes people kind of overthink this one, and this one will actually go pretty quick. All right, let's say you're just doing y equals 3x squared. And we're going to do all those same things again. All right, A value is 3. Where are the B and the C values? They're not there, right? And if there's nothing there, that means they are 0, right? Yeah. So if there's nothing back here, then your B and your C values are just 0. And again, if the C value is 0, that means this is your y-intercept, which would be at 0, 0. And when you find your vertex, now again, with the A value, this one's positive, so we know the graph is looking something like this. And with that being at the bottom, that's going to be a minimum when we graph this thing. And we're still going to do the same thing for the vertex. It's still negative b over 2a. But the b is 0. So what happens when you have 0 over 6? It's 0, right? And to get the k value, we're going to plug in that 0 into 3x squared. So what is 3 times anything squared? Yeah, if that's 0, 0 squared is still 0. That's 3 times 0, which is still just 0. So this is one of those kind of weird things where the vertex is the y-intercept. So that part of it, it's the same thing. And that makes the graph a little bit different. This is one where you have to use that a value to help you find the next point you're looking for, because the y-intercept is the same thing as the vertex. So you're kind of doing both of them here at the same time. So it's kind of one of those weird things there. All right, axis of symmetry. Still the x value, which is 0. We said this one had a minimum value. Well, that's still the y value, which was still 0. So if it's 0, 0, everything about this thing is 0. The axis of symmetry, the minimum value, all that stuff is still at 0, 0. Now, because these are zeros, they're not going to ask you for the graphing form of this one, because that one, that's it. That is the same thing as your graphing form, or your vertex form, because they're all zeros, so there's nothing to put in the parentheses because there's nothing there. So now we're just going to graph it. And this one, you don't need a very big graph. Probably 3 lines up and a couple either side. That's about all we have to have. Okay, so vertex 0, 0. So right there. And again, that's also the y-intercept. So this one, it doesn't help us to plot the y-intercept because it's the same point. This time you have to use your a value, which was 3. So that means our kind of slope is going to equal 3 over 1. So from here, we're going to go up 3 and over 1 to the right side, and up 3 and over 1 to the left side. Okay, again, domain is always negative infinity to infinity. Again, this one we know it's the minimum, so that's going to be where you start. So you're going to start at 0, and then we're going up to infinity. And if they had asked about which way this is, your y values, again, because it's going up, it's going to be greater than or equal to 0, because you're going from 0 to infinity, so 0 is the lowest number you've got.